Okay, so here's an example of how we can do step one, which is evaluating with the problem that we just did. So here's the problem that we just did. And our solution, which I guess you can't see because of this thing at the bottom, which I can't seem to move, was 2x squared, negative 2x squared minus 2x over x minus 2, x minus 1, x plus 1. So what we're going to do is we're going to plug a number into the original problem right here. The problem that we were originally assigned. So why is it still black? So we're going to plug a number into, I'll just circle it here, the original problem. And then we're going to plug a number into our solution, which is down here. And then we're going to see if those two are the same. So the only thing we want to be careful about is the number that we pick to plug in. We don't want it to be one of the restricted values because then, of course, we won't be able to plug it in. It won't work. So I'm going to pick 5. Again, it could have been any number. So I'll grab my calculator and I'm going to plug 5 into the original problem. So I have 2 times 5 divided by 5 minus 2 over 5 plus 1. And then I'm going to subtract 4 times 5 over 5 minus 2 and 5 minus 1. And I wound up with a decimal, which I don't love. So I'm going to switch it to a fraction by clicking this button here, and I get negative 10 ninths. So when I plug it in, I get negative 10 ninths. Okay, now we'll actually do the math and see what happens. We already did that, so I'll just type in the answer that we did on the previous slide. 2x squared, I don't know why all my work just went away, minus 6x divided by x minus 2, x plus 1, x minus 1. Okay, so that is my solution. So now what I'm going to do is plug that same number into my answer and see if I get the same value out. So I will plug 5 everywhere there is an x. So I have 5 squared minus 6 times 5, that whole thing divided by 5 minus 2, 5 plus 1, and 5 minus 1. As you can see, I got the same answer when I plugged 5 into the original problem and when I plugged 5 into the solution that I had gotten. So I can say, at least with certainty, that if x is 5, then I solved the problem correctly. If x is 5, then this expression here is equivalent, then this expression here is equivalent to this expression here, because when x is 5, I get the same solution for both. Okay, so I've shown that this, I did the problem correctly as long as x equals to 5. Hopefully everybody in your team picks a different number, and then maybe you'll be even more convinced you did the problem correctly because you'll have solutions for a couple different values of the variable.